Hello learners, welcome back to our channel. Today we are going to see the important topics to be covered in physical chemistry while preparing for CSIR and GATE examinations. Physical chemistry is the only portion where you can expect direct questions. The one who loves numerical problems, they can easily earn marks in physical chemistry. Only thing is that you need to know some important equations and law. When you start with physical chemistry, you begin with molecular spectroscopy. In CSIR and GATE examination, this is most important part in physical chemistry. Here you learn about rotational spectroscopy. You can refer Fundamentals of Molecular Spectroscopy by Banwell for covering molecular spectroscopy. So in rotational spectroscopy, you can expect questions from the diatomic rigid rotor, rotational line spacing, the relation between rotational constant and moment of inertia, the relation between rotational energy and rotational constant, moment of inertia and the bond length, and then you also learn about different types of polyatomic rotors. Then you learn about vibration spectroscopy. There you should know about 1D simple harmonic oscillator. So learn about Hooke's law, then problems related to that, rotation vibration spectra of diatomic molecule, then vibrational spectra of polyatomic molecules, then go to Raman spectroscopy. Then you also learn about electronic spectroscopy, Frank-Quantum principle. There you also need to know about metal-metal transition, electronic spectra of conjugated molecules, etc. Then you will learn about resonance spectroscopy. In a resonance spectroscopy, you need to concentrate on NMR, ESR, NQR, and Moss-Bayes spectroscopy. So learn the physical aspects about the origin of spectrum. In ESR and NMR, you may get the problems associated with G factor and magnetic moment, etc. So in NMR, you may also need to know about predicting the number of signals and its spin multiplicity, then their relative intensities, that is using Pascal's triangle. Then learn about coupling constant, Karplus equation. So refer Banwell for learning all these concepts. So in molecular spectroscopy, you can expect 8 to 12 marks in CSIR examination. Then you learn about quantum mechanics. In quantum mechanics, learn about particle in 1D box, 3D box, then hydrogen atom, then molecules with more than one electron, etc. Then concentrate on perturbation theory, variation theory, Hamiltonian and Hermitian operator, etc. So for quantum, you can refer Puri Sharma Patania. Then go to group theory. So this also you can learn from the same book. So you should know about point groups, Mulliken symbol, and great orthogonality theorem. So the questions related to finding out the number of 1D, 2D or 3D reducible representation by giving the character table. So you will be given the character table and you will be asked to find out which irreducible representation will be IR and Raman active modes, etc. So those type of questions will be asked. So in group theory, you can expect 8 to 12 marks in CSIR examination. Then move on to thermodynamics. So in that you learn about first, second and third law of thermodynamics, zeroth law. You should know about Maxwell's relations. So all the formulae need to be known. In Maxwell's relations, you may expect sometimes even for 4 marks. Then learn about heat capacity, Le-Chatelier principle, Trotton's rule, Clausius-Clapeyron equation. So this also you can refer from Puri and Sharma. Then move on to chemical kinetics. This is most important part. You will be asked almost 12 to 18 marks in chemical kinetics. So here you learn about rate equation for first and second order reactions. You just learn the nth order reaction. If you know the nth order reaction, the general equation for rate constant for nth order reaction, you will be able to answer the problems related to the rate constant, half-life time. So general formula if you know, so you can just apply to any order reactions. So learn about collision theory, transition state theory, unimolecular and bimolecular reactions, parallel and reversible reaction, also steady state approximation. Then concentrate on electrochemistry. Here you learn about reduction potential, Nernst equation, Kohlrath's law, Debye-Huckel theory, and liquid junction potential. So you may be asked some numerical problems in electrochemistry. So you just work on that. Then move on to surface chemistry. Here you should know about all types of adsorption isotherm, then physisorption and chemisorption relations, etc. Then move on to polymer chemistry. So there you will be asked some problems related to molar mass. So determining the molar masses of macromolecules related to viscometry, osmometry, light scattering and turbidity, etc. Then you concentrate on phase diagram. So it's a vast area. So in phase equilibria, you at least learn about the one component system like water, carbon dioxide. So you should know about the problems related to degree of freedom in that. Then move on to solid state chemistry. Here you should know about Bragg's law. So questions will be asked based on Bragg's law. So this will be available in Puri and Sharma, but still you can also learn the concept better in Huey. Learn about Miller indices, interplanar distances, and 7 crystal system, 14 Bravais lattices, and also learn about packing efficiency and radius ratio. In solid state chemistry, you may expect almost 6 to 8 marks. So totally, if you are thorough, so 70 plus marks can be scored if you are thorough with the topics discussed here. So you can have the habit of learning every day. This will help you to gain more marks with excellent ranking in the competitive examination. So do smart work, study smart, thorough with the concepts what you are familiar with. So just read again and again, crack the exam well. Thank you all for listening.